Steve's favorite clothing store is having a weekend sale. He notices that the price of jeans has been marked down by 15%, so he buys 2 pairs. If the original price of each pair is Y dollars, write an expression to show how much money Steve spent on jeans. The original cost of each pair of jeans is Y dollars. The discount is 15% of Y. That is 15Y over 100, or 0.15Y. So, the discounted price of each pair is Y minus 0.15Y. We can simplify the expression Y minus 0.15Y by assuming a coefficient of 1 on the first value of Y. Y minus 0.15Y equals 1Y minus 0.15Y. Rewrite using a coefficient of 1. Equals 1 minus 0.15 times Y. Factor out Y from both terms using the distributive property. Equals 0.85Y. Subtract. The intermediate expression we found shows that subtracting 0.15 of the price from the price is the same as multiplying the price by 0.85. Said another way, 15% less of Y is the same as 85% of Y. So, Y minus 0.15Y is the same as 0.85Y. Since Steve bought 2 pairs of jeans, we multiply 0.85Y by 2 to arrive at the final answer. 2 times 0.85Y equals 1.70Y. Steve bought 2 pairs of jeans where the total cost of the jeans in dollars was 1.70Y. Suppose Steve paid 3/5 of the billed amount using a gift card and then paid the rest of his bill with cash. Let's write an expression for the amount he paid in cash. The amount.
So at this point, we took a simple problem and made it really difficult. You got a pair of jeans and it's 15% off. You buy 2 pairs of jeans. It's the equivalent of saying 1.7 multiplied by Y is going to be how much you spend. Then we make it more difficult by considering, well, we don't usually go to the store and only play with a debit card or only pay with cash. After the holidays, we might have gift cards. So he's now going to pay with the gift card. He's only going to pay 3/5 of the cost. Why? I don't know. Maybe he wants to save 2/5. If he has $50, maybe he wants to save $20 of his gift card for some V-Bucks. So he spends $30, 3/5 of his deal there, 3 out of 50, let's say, or he has $100 and he spends 60 out of 100. Either way, it's the same ideal, I believe. Okay, so to find the amount he paid, let's continue.
What Steve paid using the gift card is 3/5 of 1.70Y, or 3/5 times 1.70Y. To find the amount he paid in cash, subtract the amount paid by gift card from the total billed amount, 1.70Y. 1.70Y minus 3/5 times 1.70Y. Then, simplify the expression. 1.70Y minus 3/5 times 1.70Y equals 1.70Y times 1 minus 3/5. Factor out 1.70Y using the distributive property. Equals 1.70Y times 5/5 minus 3/5. Rewrite using a common denominator. Equals 1.70Y times 5 minus 3/5. Simplify. Equals 2/5 times 1.70Y. Apply the commutative property. So, the expression 2.
What the term was. So in this case, apply the commutative property. So I immediately just looked it up. And as you might be able to see, the commutative property states that the numbers on which we operate can be moved or swapped from their position without making any difference to the answer. For example, 3 times 11 times 2 would be 33 times 2 would be 66. Or 3 times 2, which would be 6, times 11 is 66. In this example, A plus B is the same as B plus A. 5 minus 3 is 2/5 multiplied by 1.70y is the same as 2/5 multiplied by 1.75. They just flipped it using this commutative property. Just thought I would explain that to you. And if I'm going to go through the trouble of grabbing the notes, looking it up and then putting it in my notes, I'm going to then take this and copy my notes and add them to my guided notes when I start to fill those out. Hopefully I don't forget to do that step, but I do hope that I remember, because then on the test, when it says rewrite this using the commutative property, I have that. Or when it says what is the definition or something, I'm just thinking ahead. If I don't know it here, it could be on the test, and I want to make sure that I record my understanding of it. Okay.
5 times 1.70y represents the amount that Steve paid in cash. Notice that his cash payment is the product of 2/5 and the total billed amount. This result shows that 3/5 less of a quantity is the same as multiplying that same quantity by 2/5. You've seen how to solve a variety of percent increase and percent decrease problems. Next, you'll watch a video about writing an expression for a percent increase that exceeds 100%.
So, I'm 100% sure. Well, now this is 300% sure. It just means instead of having 100% of a pizza, you have 3 pizzas, then you have 300% of pizza. It's not as difficult as it sounds. We just have a little more math.
On behalf of the executives at Email Palace, I want to clear the air. Some believe we are misleading our customers when we say that we can increase the amount of storage space for your emails by over 100% from your current email account when you use Email Palace. For example, our latest offer can increase your email storage space by 125%. But some are skeptical. Sound a little confusing? Yeah, that's why we want to clear the air. Let's say you currently have 400 gigabytes of storage space. An increase of 100% means that the number of gigabytes will double. I know what you're probably thinking. How does Email Palace handle the extra 25%? Well, that 25% needs to be added to our 2 previous values to arrive at 125%. Because 25% of 400 is 100, the total number of gigabytes for your new email storage space is 900. To clarify, Email Palace wants you to realize that your new email storage space would be 125% greater than your current email account's storage space, not 125% of your current email account's storage space. That's a win for you as the consumer, and that's an Email Palace guarantee.
In the video, you saw how to rewrite expressions involving percentages. When working with percentages, be sure to distinguish between the phrase increase or decrease by and the phrase increase or decrease to in the problem. These 2 phrases do not mean the same thing. Consider this example. A property on York Street increases by 300% of its original value, Y. A nearby property on Zion Court increases to 300% of its original value, Z. Write the increased value of each property in terms of Y and Z, respectively. The current value, Y, of the York Street property increases by 300%. So the new value of the property is given by this expression, y plus 300% times y. We can simplify the expression. Recognize that 300% is the same as 300 over 100. Y plus 300% times y equals y plus 300 over 100y equals y plus 3y equals 4y. The equivalent expression we found shows that increasing by 300% is the same as multiplying the original value by 4. Now we turn our attention to the Zion Court property. In our example, this property increased to 300% of its original value, z. The new property value is 300% of z, or 300% times z. We can simplify the expression, recognizing that 300% is the same as 300 over 100. 300% times z equals 300 over 100z equals 3z. This equivalent expression shows that increasing to 300% is the same as multiplying the original value by 3. You've seen that the phrases increase or decrease by and increase or decrease to convey different meanings. For example, increasing by 300% is the same as multiplying by 4, whereas increasing to 300% means multiplying by 3.
There is no way I'm going to remember that. I'm going to add that to my notes. To read the directions on the question, type your answer in the box. Avery owns stocks in Everrise Corporation. The stock price increased by 120% over the past week. If the price was P, write two equivalent expressions that represent the current stock price and explain what their equivalence means. Substitute one or more variables into the expression to prove them equivalent. All right. From previous expressions, we know that there is not an equal sign or an equal greater than type sign, no quality or inequality. And so we have P, the price last week, plus 1.2P, whatever the price was last week. And we know that it increased, so it's 1.2. The percentage 120% is written as 1.2 in decimal form, 1 being the 100 and 0.2 being the 2/10 or 20 here. If, and because we know that it was the price plus the increase of the price of the stock, P plus 1.2P is the same as 1 plus 1.2. 1 plus 1.2 is 2.2P. So we have the two expressions. It says write two equivalent expressions that represent the current stock price, okay, and explain what their equivalence means. Substitute. So this means that they are equal. Oops. I did not mean to yell in that, but I'm not going to fix it at this point. So because they're equal, it's the same as increasing a value by 120% is the same as multiplying the original value by 2.2. And looking back at our notes, that increasing by 300% is the same as multiplying by 4, so more than the number originally, how many you had originally. Whereas increasing to 300% means multiplying by 3. So here we're not multiplying by 1.2, or 120%, we're multiplying by 1 more than 120%. So this is that 1 more. This is the 1 more. And because it says by, we know we're on the right track. Okay. Next, for example, assume that P equals 50. So we're going to do a practice one here. So it says substitute one or more variables into the expression to prove them equivalent. So if I say P equals 50, and then I solve 50 plus 1.2 times 50 multiplied by 50, because P and P, so show you here, P equals 50. So if P equals 50 and 1.2P is the same as saying 1.2 multiplied by 50, because P is 50, that's how we set that up. All right, so then we could use our calculator, our handy dandy calculator, and say 1.2 times 50, so that equals 60, plus 50 equals 110. Okay, so then we'll check the second one, because they want to prove that they're equivalent. We're going to prove by putting in the same number. So again, P equals 50. So 2.2 multiplied by 50, P equals 50, right? Equals, so let's try it, 2.2 multiplied by 50 equals 110. So it checks. I could go check. All right, checks out. Then I erase all that because that's just craziness right there. Okay, so we have that and we can move on.
More equivalent expressions. So far, you've worked with equivalent expressions that have one variable. Now, let's rewrite expressions that have two variables. You'll apply the same concepts and strategies that you used with single variable expressions. Melanie is tiling her shower with blue and white square tiles. She needs enough tiles to cover 72 square feet. Each tile is the same size. To get the look that she wants, Melanie will use X blue tiles and Y white tiles per square foot. In the following activity, you'll write a two-variable expression in different forms to represent the number of tiles that Melanie needs for her shower.
More equivalent expressions. Woohoo! This activity will help you meet these educational goals. Mathematical practices. You will make sense of problems and solve them, reason abstractly and quantitatively. Attend to precision, look for and make use of structure, and look for and express regularity in repeating reasoning. Directions. Read the instructions for this self-checked activity. Type in your response to each question and check your answers. At the end of this activity, write a brief evaluation of your work. Activity. Melanie is tiling her shower with blue and white square tiles. She needs enough tiles to cover 72 square feet. 72 and then square feet. You can do that. Each tile is the same size. Okay, good to know. To get the look she wants, Melanie will use X blue, so X equals blue tile, and Y equals white tile. Okay. Now, I know that information is up here, but it helps when you write down the information so that way you know that you're pulling the information off and putting it down here. I can't always work with the information up here. I can work with it down here, moving it around and setting up my problems. So it says write an expression in terms of X and Y that represents the total number of tiles needed per square foot. Now, it doesn't say that it's the same number of tiles, but let's continue. Simon, get down. So we look at X plus Y, X plus Y equals what, 72 square feet. So X plus Y equals 72 square feet. How many Y tiles we need, or blue tiles we need, how many white tiles we need, equals 72 square feet. All right. So there we go. We wrote an expression in the form in terms of X and Y that represents the total number of tiles per square foot. So this is 72 square feet. So if we're going to get down to 1 square foot, I bet we're going to have to divide by 72 at some point or something like that. Okay. All right. So we submit that. Expression X plus Y represents the total number of tiles needed per square foot. Awesome. Now, write an expression in terms of X and Y that represents the total number of tiles needed for 72 square feet. Okay? So in order to write an expression in terms of X and Y that represents the total number of tiles needed for 72 square feet, we're looking at 72 square feet multiplied by the number of X tiles plus the number of Y tiles. Now, as you see, the reason why we use parentheses for multiplication, or we use a asterisk, this symbol right here, instead of a X, is because sometimes we use X as a variable. So that's why we get away from that. If you missed that somewhere, I thought I'd let you know. Okay, so 72 square feet multiplied by the number gives us one way to represent the total number of tiles needed for that many square feet. See? Okay. Use the distributive property to write an expression that is equivalent to the expression you wrote in part B. So remember, the distributive property allows us to distribute that 72 across the x and across the y. Remember, that's the one where we go whoop and whoop like that. So it then becomes 70 over here, 72 times x, or in this case x, plus 72y. Oops. 72x plus 72y. Okay, so we just rewrote the expression and it is equivalent to the one we wrote over here. So this allows us to work with it a little bit more readily available, to use. So we got 72x plus 72y. Checks out. Okay. The expression in parts B and C are equivalent. Explain what this means in terms of Melanie's situation. So the expression in parts B and C are equivalent. How? Why? Well, in the expression 72 multiplied by x plus y, this expression finds the number of tiles in a square foot and then multiplies that sum is the answer of an addition problem, by 72. The other way is 72x plus 72y. This expression finds the number of blue tiles in 72 square feet and adds them to the number of white tiles in 72 square feet. Total number of tiles in 72 square feet. And then we want to do our self-evaluation. This is pretty tricky to me because of laying out the x and the y, the multiple variables, and knowing that they're the same. Remember, go back through your notes and make sure that you title everything. Give labels. Label your work. That helps you keep it straight. Label your work. All right, and write more here. Oh, I saved an exit. Let me go back.
You've learned to write expressions with two variables to represent a scenario in several ways. Here's another situation involving multiple variables that we can model using equivalent expressions. Theo is visiting a theme park with his friends. At the souvenir shop, he buys K keychains and P photo frames, where each chain and frame costs $2.49. He also buys a T-shirt for $5.99. What is the total cost of Theo's purchases in terms of K and P? We can represent the total cost in two ways. One way is to find the cost of each item and add them up to find the total cost. The unit price of the keychains and photo frames is the same, $2.49. So, the cost of K keychains is $2.49K. The cost of P photo frames is $2.49P. The cost of one T-shirt is $5.99. Adding these costs give the total cost. 2.49K plus 2.49P plus 5.99. Another way to find the total cost is by multiplying $2.49 by the total number of keychains and photo frames, K plus P, that Theo bought since both items have the same unit price. Then, complete the expression by adding the cost of the T-shirt, $5.99. 2.49 times K plus P plus The two expressions that represent Theo's purchases must be equivalent. That is, they must be equal for any given values of the variables. Let's check for equivalence of these two expressions by rewriting the first expression to match the second. First expression, 2.49k plus 2.49p plus 5.99. Second expression, 2.49 times k plus p plus 5.99. Notice that 2.49 is a common factor for the terms 2.49k and 2.49p in the first expression. Use the distributive property to carry out the factorization. 2.49k plus 2.49p plus 5.99 equals 2.49 times k plus p plus 5.99. In just one step, we verified that the two expressions are equivalent. We could have chosen to rewrite the second expression, 2.49 times k plus p plus 5.99, to check for equivalence with the first. In this approach, we use the distributive property to expand part of the second expression. 2.49 times k plus p plus 5.99 equals 2.49k plus 2.49p plus 5.99. Remember that representing a scenario using different expressions does not change the result of the scenario as long as the expressions are equivalent.
Type your response in the box. A supermarket sells fruit snacks by the box. Fruit snacks. Each box holds X packages of strawberry snacks and Y packages of cherry snacks. Nina bought 6 boxes. All right, so if she bought 6 boxes multiplied by X minus Y, and remember the distributive property, so 6y minus, let's do 6x minus 6y. Okay, so those are the same. All right, the first expression shows subtracting the number of packages of cherry snacks from the number of packages of strawberry snacks in each box, and then multiplying them by the number of boxes, multiplying the difference. Remember, the sum is the answer to an addition problem, and this is the difference between the number of x's and the number of y's, or the number of strawberries and the number of cherries. Fruit snack packages. Okay. That's the same as finding the total number of cherry snacks and subtracting the total number of strawberry snacks. Subtracting the total number of cherry from the total number of strawberry snacks. Okay? They are equivalent expressions.
Two expressions are equivalent if either expression can be rewritten as the other by applying the properties of operations or by combining like terms. You can apply the distributive, commutative, and associative properties.
Associative property is a property that states when 3 or more numbers are added or multiplied, the sum or the product is the answer of a multiplication problem, the sum is the answer of an addition problem. Either way, when the 3 or more numbers are added or multiplied, the sum or the product is the same regardless of the grouping of the addends or multiplicands. So 3 plus 4 plus 5 equals 12. Even if you did 3 plus 5 plus 4 would still equal 12. 4 plus 5 plus 3 equals 12. And multiplication is the same. So 2 times 8 times 3, 2 times 4 times 3, 2 times 4 equals 8 times 3 is the same as 2 times 4 times 3 equals 24. 3 times 4 equals 12, times 2 is 24. So it's the same way, or same, just you can put them in different orders. It doesn't change the value. Okay. So if you want to add that definition, the associative property, bada bing, bada boom, and it says that it does not work with subtraction or division. I'm just going to throw that into my notes here just for giggles. Again, I'm going to use these when I do my guided notes. So why not? I already took the time to look it up. Okay, let's continue with the summary. Thanks.
Original expression. Equivalent expressions give the same result no matter what values you substitute for the variables. Equivalent expressions also help to shed light on a problem and on the process used to solve the problem. Understanding equivalent expressions can help you find the easiest or quickest method for arriving at a solution.
Congratulations, you've completed the tutorial on equivalent expressions. Good luck on the mastery test. You got this.